Hey, sixth graders, this is the video lesson for lesson 3, day 2, and you are going to be exploring equivalent ratios some more. So as you watch this video, remember you should first have your book open. You should have it on page 18 right now. Second, as I give directions throughout the video, I'm going to tell you to pause the video, do some problems. Make sure you do that and follow those directions because that's how you're going to learn the most. Third, make sure you complete everything on pages 18 and 19. No big deal if you make a mistake. You can pause it at any time to fix it. You could go back and rewind and watch it from any point. All right, so now let's get started, and we are going to talk about some equivalent rates. So on page 18, you're basically just going to stick with me as I go through some stuff. When we get to page 19, that's when you're going to be doing some problems. So here's what it says. It says, read the problem below, then explore different ways to show equivalent ratios. So this says a cafeteria worker knows that it takes 3 bottles of juice to serve a table of 18 students. How many bottles of juice are needed for 24 students? How many bottles of juice are needed for 42 students? So in this problem, I'm going to underline some important information. It takes 3 bottles of juice to serve 18 students. So if you think of that as a ratio, 3 bottles to 18 students. But then it's going to ask you some questions. How many bottles are needed for 24 students? And how many bottles are needed for 42 students? All right, so first, let's take a look at the different ways to show equivalent ratios. So first, the picture it method. It says you can draw a diagram to represent a ratio of 18 students to 3 bottles of juice. So here are your 18 students. Here are your 3 bottles of juice. Now, the cool thing about this is, let me erase those circles, is it also splits it into an equivalent rate of 6 students to 1 bottle. So you see how that kind of can help you out in a little bit. All right, now the model it says, in addition to drawing pretty pictures with faces and bottles, you can also make a table to show the ratios. So remember up here, the original ratio they gave us was 18 students for 3 bottles, right? But notice here the way it's grouped as 6 students per bottle. You have 6 students for 1 bottle, 12 students for 2 bottles, etc. And then it keeps going up. You can do 4 bottles, 5 bottles, 6 bottles, 7 bottles. You can do any amount of bottles that you feel like doing. So the tables come in handy in answering questions about ratios. All right, so you can keep referring back to these pictures as you answer some questions on the next page. So now make sure you're on page 19. So this page is going to be divided into a couple different types of questions. Now here is your first job. Your first job is going to be to try 2 through 6 on your own. And you're going to pause the video while you do those, and you could restart it when you're done. Now, the only thing I'm going to ask you is, if it says explain or tell me how, then yeah, you have to write a sentence or 2 explaining and telling me how. If it doesn't say explain or tell me how, and it just says show or answer the question, then you don't have to explain. All right, so remember, you make a mistake, so what? You'll fix it. As long as you try and you learn from it. If you're not sure, give it your best shot. Again, no big deal. Pause the video, do 2 through 6, restart it when you're done. Go. All right, so let's see how you did. We are going to start with number 2. It says, what is the ratio of number of students to the number of bottles of juice? Now, what I'm going to do is I'm going to put the picture here so we can see it. Give me a second. Okay, so now I just put the picture there so we can look at it and answer question 2. So in question 2, we have to find the ratio of the number of students to the number of bottles of juice. So, 1 originally, they just said it was 18 students to 3 bottles of juice. Remember, all 18 are right here. All 3 bottles are right here. Now, if you wrote the reduced one, 6 to 1, that's fine. You don't have to change that. No big deal. That's the rate. So, no biggie. All right, so let's slide down, and we'll look at problem 3. So problem 3 says, what is the related rate for this ratio? Explain how the diagram represents this. All right, so the related rate, which I guess I talked about a little bit on the previous page too much, is 6 to 1. Now, as far as how the diagram represents this, I'm just going to say, if you looked at each one of these three groups that I just circled, it kind of shows you the related rate. It shows you how many students per bottle. So I'm going to say that. I'm going to say the diagram shows 6 students for each bottle of juice. Now remember, you do not need to have the same exact words as me, but you could have something along those lines that you could see the 6 for 1 from that diagram. Okay? Now, I'm going to go down to question 4. Okay, so in question 4, it says, look at the table. What is the unit rate? Tell how you know. So in this one, we're looking at the table, which I'm circling at the bottom right here. And it says, what is the unit rate, and tell how you know. Well, the unit rate is 6 students. And when it says tell how you know, well, it's kind of easy when you look at the table. Remember, it's the number that is above the 1, right? So if here's the 1, it's the number that's above it, 6 students. So I'm going to just write the table shows the 6 right above the 1. That's really all you need to know about that question. No big deal. All right, so remember, you can pause at any time, and you don't need my exact words. All right, so let's go down to number 5. Okay, so for number 5, it says use the unit rate to complete the table. How many bottles are needed for 24 and 42 students? Now remember, this was the question they originally asked us on the previous page. So this is where the table comes in handy. So I have the table blown up right below number 5, and you should have that filled in on the other page. If you didn't fill in the table on the other page, make sure you pause the video and go back and fill it in before you watch this answer. All right, so now, anyway, when I'm filling this in, there's 2 ways to fill in the table. One is, if you are going this way, notice that the number of students increases by 6 each time. Because 6 plus 6, 12 plus 6, so you can just count by 6. You could say 24 plus 6 is 30, plus 6 is 36, plus 6 is 42, right? The other way to do it is if you figure out the rule that the number of bottles of juice is 1, the number of students is 6, that if you go from the bottom up onto the top, the number of students is 6 times the bottles of juice. So 2 times 6 is 12, 3 times 6 is 18, 4 times 6 is 24, 5 times 6 is 30, 6 times 6 is 36, and 7 times 6 is 42. Now the main thing is, as long as you have these numbers here correct, you're good, however you did it. But I wanted to show you 2 ways you can do that. Now let's answer the question for 5. How many bottles are needed for 24 and 42 students? So I'm going to say 24 students to 4 bottles, because it's just right here in the table. And for 42 students, 42 students need 7 bottles. Notice it didn't ask us to explain, so you don't have to explain that one. All right, so if you had those right, good. If not, pause and fix your mistakes. And let's go down to number 6. Okay, so in number 6, it says, how do you use a table to show equivalent ratios? So remember in my table, I'm going to rewrite my numbers in there because I just had to erase them. So this is something, as long as you have it in your own words, you're okay. So I'm going to say, in a table, I could either count by 6, I'll say count by 6 students, to find equivalent ratios, or you can multiply the bottles of juice by 6. So remember, if you didn't have my answer, no one's going to have my answer, right? We're all different people. That's fine. Yours might be better than mine. So I explained to me how I could use this table to find equivalent rates. I said you could either count by 6 or you can multiply these numbers by 6. If you explained it in a way how you found it, that's fine. All right. So now let's continue on with number 7 and 8. Now in 7 and 8, you did not do these yet. You were not supposed to do these yet. So here's what I'm going to have you do. I'm going to have you, now 7 and 8 are different. They have nothing to do with that diagram with the bottles of juice and the students. These are different problems. So what I want you to do is I want you to try number 7. So answer the question, and you can do a table, or if you want to draw a diagram, just like we did on the previous page, to help you solve this. If you can answer it without those and you get it right, that's fine. All right, so do number 7 only. Don't do number 8 yet. Pause the video. As soon as you're done with your 7, restart it to see if you were right. Go. Okay, let's see how you did in 7. It says Michaela travels 15 blocks on her skateboard in 5 minutes. At this speed, how many blocks can she travel on her skateboard in 12 minutes? All right, so what I'm going to do is I'm going to kind of set up a table here. I'll do a table for this one. Maybe in the next one I'll do a diagram. So I'm going to set up some numbers. And I'm going to have blocks and minutes. Now for minutes, since it's 5 minutes, I'm going to do 1, 2, 3, 4, 5. And I'll add 6 just because I have a block there. All right, now I know she can do 15 blocks, right? So in 5 minutes. Now here's what I'm going to see. To go from 5 to 15, can I zoom in on it? Yep. To go from 5 to 15, I noticed that 5 times 3 is 15, right? So I can use that to basically fill in my table. So all of the numbers, the number of minutes multiplied by 3. So 1 times 3 is 3, 2 times 3 is 6, 3 times 3 is 9, 4 times 3 is 12, and 6 times 3 is 18. So now it says, at this speed, how many blocks can she travel on her skateboard in 12 minutes? Well, guess what? My table doesn't cover that because it says 12 minutes. I'm only up to 6 minutes. But you know what I can do? I'm going to skip 7, 8, 9, 10, and 11. If I just put a 12 here, I know the rule is times 3. 12 times 3 is 36. So the answer to this is 36 blocks in 12 minutes. Now, you did not need to do a table for that. That's just how I solved this one. But if you had the answer right, whatever you did is great. Now, if you had the answer wrong, then maybe learn from it and try using a table like this to do number 8, because that's what you're about to do now. All right, so number 8, I want you to try this one on your own. If you made a mistake in 7, learn from it when you do 8. Pause the video, do 8, restart it when you're done. Go. All right, so here's what 8 says. It says, a seamstress uses 12 yards of fabric to make 3 costumes for students in the chorus. So I'm going to underline that. 12 yards of fabric for 3 costumes. How many yards will she need to make costumes for all 25 students in the chorus? All right, so let me set this up. I'm going to do a table. I don't like drawing pictures because I'm not good at it. All right, so I'm going to do yards on top, and I'm going to do the number of costumes. So I'll split it into some sections. Remember, I can add as many of these sections for my table as I want later on. So 12 yards for 3 costumes. So this would be 1, 2, 3, 4, 5, 6 costumes. And I know it's 12 yards for 3 costumes. Now I also know that 3 times 4 gets me that 12, right? So if I multiply the number of costumes by 4, I'll get the yards. 1 times 4 is 4, 2 times 4 is 8, 4 times 4 is 16, 5 times 4 is 20, and 6 times 4 is 24. So this wants to know is how many yards will she need to make costumes for all 25 students? Okay, so let's think about this. Let me get my pointer ready. If she makes 24 yards for 6 costumes, and the rule is times 4. Now remember, I'm going to add on to my table, but I don't need to do 7, 8, 9, 10, etc. I can just jump the number of costumes. So there has to be 25 students, so that's 25 costumes, right? So I'm going to put my 25 right here. I'm just skipping all the numbers between 6 and 25, because if you know the rule, it's going to be easier. So remember, the rule is times 4. So I just have to do times 4. So what's 25 times 4? It's 100. So the answer to this is 100 yards. All right, if you had that one right, great. You didn't have to do it like I did it. If you had it wrong, I want you to pause it and fix it. Do a table, because they will help you throughout the rest of this lesson. All right, but anyway, you're done with me. So we're done with this lesson. Make sure everything is filled out and all corrections are made on pages 18 and 19. Thanks, guys.